part B now. So again, the question is, can we write B as a linear combination of the columns of A? So again, we're going to put this into a matrix. And I'm going to cheat here. Okay, maybe the first step is to say that this vector equation is equivalent to the matrix equation AX equals B, which is equivalent to solving an augmented matrix like this. Okay, then when we write down the augmented matrix, we get this guy, where my B is appearing over here. And this is the coefficient matrix A. And then 1, 2, skip a few. I'm skipping steps to get to the reduced echelon form, which I'll now use because this is a consistent. This is now a consistent system, we can see. So we can write down the general solution. So I'm going to go ahead and put the general solution in vector parametric form. But first we translate these two rows, these two non-zero rows, back into equations. We get x1 plus 2x3 plus x4 is equal to 1. And then x2 minus x3 plus x4 is equal to 2. Now, the variables that have leading entries, I solve for those two. So we're going to solve for x1 here, we're going to solve for x2 here. Okay, and then I take all this information and load it into a vector of variables. So x1 gets replaced with this, x2 gets replaced with this. Key, and then I pull this thing apart. So we get x3 times a vector minus 2, 1, 1, 0, plus x4 times a vector minus 1, 0, 1, and then plus a constant vector 1, 2, 0, 0. Okay, this is our answer. So what have we found? Well, we found that all solutions of AX equals B. Okay, so if you want to solve this equation and find x, okay, here it is. Every x that works here has this form here. And by this, I mean the right-hand side of that equation. Also, B is a linear combination of the columns of A. Okay, we knew that a long time ago, actually. We knew that right here. We knew that here because we could see from this form here that the system is consistent. So there is a solution, meaning that B can be written as a linear combination of the columns of A. And let's say a little bit more. So B is a linear combination of the columns of A for any choice. Okay, so I can choose x3 and x4 to be anything, and I will get a linear combination of the columns of A that adds up to B. So for example, if I choose x3 to be equal to x4, and they're both equal to 0, that's the easiest thing. Then I get x1 is 1, x2 is 2, and you get the linear combination B is going to be 1 times A1 plus 2 times A2 plus 0 times A3. You don't have to write these last two things, but just to emphasize. So if I choose x3 and x4 to be 0, I get B is a linear combination of the columns of A in this fashion. And if you choose a different x3 and x4, if you want to be truly obscene and let x3 be pi squared and let x4 be negative a trillion, okay, you'll get another way to express B as a linear combination of the columns of A.